In our last video, we talked about timers in the CCW software. In this video, I want to continue that topic and demonstrate how the timers work. You'll see that I created a program that has several programs associated with it. You'll see that I have 1, 2, 3, 4, I have 5 ladder programs. Each one of the ladders has a different timer. In order to create these programs, all I did was I right-clicked on programs, said add, and add new ladder program. I won't do that because it's the same as what we did to create the very first one. In CCW, these programs are scanned in the order that they appear in this tree. There are no program control instructions. If you're familiar with Studio 5000, you know that there are jump to subroutines, JSRs, there are returns, there are the subroutine label or the sub label. Well, in CCW, that doesn't happen. All of these subroutines are scanned in the order they appear. CCW handles subroutines. In fact, they don't even call them subroutines, they're functions. And that's really the way things should be done. But anyway, they handle the routines based on functions. And in our next video, I'm going to cover creating functions. Now, I can change the order in which these routines or programs can execute. I can take a program like RTO Timer and click on it and drag it and say, okay, I want you to I want this to now be the order. Or I can drag this one down and say, I want this to be the order, so that it executes in this order. But all 5 of those programs are going to execute. Now, last time I said that I would show you how to access the Q or the done bit using the dot notation. So I'm going to, before I go online and actually start showing you how to, not show you, but demonstrate to you how the timers work, I'm going to add a rung in here, and I'm going to put a contact on that rung, and I'm going to use the dot notation to access the Q bit or the done output of this timer on delay. Now, when you look at the variable selector, you'll not see that particular timer sometimes. If I come in and just click into the table, you'll see that they appear. So I want the timer called timer on delay. So timer on delay, and I'll use the little plus sign to drill in. And here are the members, that these are called members of that particular timer object or timer instance. I want the Q. I want you to notice that you can also access the preset and the elapsed time. So I want the Q. I'm going to click on Q and say OK. And now I've got timer on delay, which is the variable name for this TON timer, dot Q. And then I'm going to actually just take this coil and move it down to this rung. Notice I just took it and drug it down to a target, because now I'm going to use this as my done bit. So that said, I'm going to now start my simulator. Make sure I've got the right connection to it. Let me turn it on. Make sure I have the right connection to it, which I do. And let's see, go back to timer on delay. And we've already demonstrated the timer on delays. Let me start downloading this. Oh, I clicked the wrong button, but that's okay. That's actually going to do the build first. Make sure there's no errors. All right, then I'm going to download it. So that we've already showed you how a timer on delay works. The only reason I'm going to run it is to show you how the .q bit works exactly the same as if I had a coil out on the Q output of this rung. So now, if this gets online here, takes a little while. All right, we're online. I'm going to toggle this bit on. The timer starts timing, and when it's done, this contact will close, which it does, and it turns on the output associated with it. So everything is the same as it was, only this time I used the dot notation to access a member of this instance. So let's go to and look at the TOF timers. Now I can either double click on the program timer TOF over here, or I already have it open, so it's in my tabs across the top, timer TOF, and POU stands for Program Organizational Unit. If you remember, and if you don't remember how that works, you could go back and look at my other video to see how timer off delay timers work, or what you can do is click on an instruction that you'd like help on and then press the F1 key. When you press the F1 key, it brings up help on the instruction that you had selected. And you can scroll through this and get the help. There's the timing diagram you saw in our last video. It shows you how it's used in function block, in ladder, and in structured text. So it tells you what or how the instruction works. So if you remember, timer off delay timers time when the timer input is false. And also it's a timer off delay, therefore the output or the Q will be on until the timer times out. Now on the very first time you do this, the input has to actually toggle to on. So I'm going to toggle this input on. You'll see that the Q output is true. This output is enabled. This is the enable on. This is the timer off with an enable. And I'm going to toggle this in on. And you'll see that the done bit turns on. Now these both of these timers work exactly the same. It's just one needs to be enabled and one doesn't. So I'm going to now toggle this off. The timer will start timing, and at the end of the timeout, this done bit or this Q goes false. When the input goes true, the timer resets and the Q output turns on. I'm going to use the Control T key on my keyboard to toggle this on and off. So I'm going to turn it off. It starts timing. I'm going to turn it back on, and it resets before it finished, just like the timing diagram says it should. So timer off delay timers time when the input of the timer is false. Let's take a look at the RTO timer. I also have it open. The RTO timer is a retentive timer on delay timer. So it works exactly the same as a TON timer with one exception. It has a reset input, which needs to be false for the timer to time and true to reset the timer. And also, if the input goes false before the timer has finished timing, the elapsed time will stop, maintain its value, so that when the in goes true again, it will continue timing where it left off. So I'm just going to use this first one because, again, the timer with the enable works exactly the same way. So I'm going to toggle this bit on. You'll see it starts timing. If I toggle this bit off, it stopped at 5 seconds, 687 milliseconds. It's not finished yet. When I toggle it on, it starts timing right from where it left off, and when it's done, the cue turns on. Now I can make that input go false, nothing reset, because I need to make this reset go true. So I'll click on that, and in this case I'll right click. I could use Control T again. Toggle. When the reset goes true, the elapsed time gets reset. Now if that stays true and I toggle this input on, notice the timer is not timing. And it's because it's constantly getting reset. So the reset has to go false, and if the input is true, it'll start timing. So a retentive timer. Let's go to the TP timer. The TP timer is a pulse timer. And if you remember how it worked, when the in goes true, whatever the PT is set for, the cue will turn on for that length of time, no matter what the input does. So let me turn that input on, and you'll see that the output goes true. 2 seconds later, it goes false, even though the input's on. When I turn the input off, the cue stays off. I'm going to turn the input on, and then I'm going to turn it off right away to show you that this timer will continue timing until it reaches the 2 seconds. And it's continuing timing at 2 seconds, or whatever your preset value is. So this created a pulse for the length of the preset when this instruction is true. One last timer, and that's the timer off delay timer, or the timer on off delay timer. And this timer has a preset for the timer on delay portion and a preset for the timer off delay portion. So it works the same as a timer on delay timer and a timer off delay timer. When this input goes true, the timer will start timing. When it reaches the 5 seconds, the done bit turns on. When I make it go false, the timer starts timing. The done bit's on yet until it reaches the timer off delay timing. So you could perform both functions on this one timer, depending on the status of the in. Okay, that's all I'm going to say about timers at this time. Those of you who are used to using the Studio 5000 software, you'll find that other than these 2 additional timers, they work exactly the same way. Those of you who are new to PLC programming, you might want to pause this video at certain spots and go in and duplicate what I have on the screen, or create your own timer program so that you yourself can watch how they actually work. One last thing before I leave this video. I'm going to go offline. So I'm going to go offline. I'm going to turn my simulator off just to show you something that I did not show you last time. I've been using one particular value in these presets. I can go into this preset, and let's say I want 2 hours. I can do this. I can say timer. Timer. I want 2 hours, 33 minutes, 16 seconds, and 54 milliseconds. So I can string it together. I can make any time I want just by telling it how many hours, how many minutes, how many seconds, how many milliseconds. And if I don't have milliseconds, I just don't include it. If I don't have minutes, I don't include it. So I think it's very powerful, and I don't have to think about converting a number into milliseconds. All right, that's it for this video. I'll be back in the next video to talk to you about functions and how to create a user-defined function. So see you then.